Hi everybody, this is Mr. Folly, and welcome to podcast 9.1, where we're going to learn, I talk about equilibrium. Equilibrium is dynamic, that's abbreviated for equilibrium. Rates are equal in equilibrium. And we're going to learn equilibrium expressions, Kc with molarity. And we're going to talk about solids and liquids for K. We're going to talk about Q and K. So let's hop right to it. So, first and foremost, equilibrium. Equilibrium, the rates of the forward and back reaction are equal. So notice it's the rates. Just to emphasize this, not amounts. And I talk about in my classroom has 24 people in it. And outside of my classroom, it's the world, right? It has 6 billion people in it, right? So there's not the same number of people in my classroom and out of my classroom. The bell rings, 24 people leave. I guess they go to 6 billion. And then 24 people come back. Okay? So the rate of 24 per passing period is the same. So the rate of 24 per 6 minutes is the same. Right? Sugar on the bottom of iced tea does the same thing. Where if I have a cup of iced tea and I have some sugar particles here, what happens here is if I have something dissolved, I'll make those X's. One will precipitate out, and one of these will turn into an X. Okay? So they do that at the same rate, but there will always be some sugar sitting on the bottom. Sugar. And possums and car wash employees, so if you remember in biology class, you'd have a little possum. I guess I should have made them. And they would be eaten by somebody, so there might be somebody going down to grab them and eat them. So I worked with a guy that ate possum. I think I might have told you that story. So, and then they showed a little graph where if the number of possums got really big, then the number of hillbillies would come along and eat the possums, and they'd come down. So then there would be the trailing one. So you get up, you go down, you go up, you go down, and you eventually reach an equilibrium where you have a pretty steady number of possums and a pretty steady number of possum eaters. Usually it's rabbits and foxes. What does dynamic mean? Dynamic means moving. The equilibrium is dynamic and never stops. Isn't this picture really creepy? So that means that when you're at equilibrium, it doesn't stop. It means you get the same number of kids up as you have kids back. Actually, it would be the rate of kids going forward equals the rate of kids going backwards. Equilibrium expressions. Equilibrium concentrations are constant. So a ratio of products over reactants exists. Okay? And it is probably not equal to 1. Okay? It could be, but it probably won't be. So K is just a ratio. K stands for the equilibrium constant, and it's just a ratio of products. It's just a ratio of products over reactants. Okay? So product 1 raised to coefficient, product 2 raised to a coefficient, reactant 1 raised to coefficient, reactant 2 raised to coefficient. And then the bracket means we're in concentration, so small. This will make a lot more sense when we do sample 1. So see how I have a coefficient of A, coefficient of B, coefficient of C, coefficient of D. Hey, they're my coefficients. Okay. Reactant, reactant. Notice reactants are on the bottom. Product, product. You notice your products are on the top. Okay. Kc expressions do not include values for pure solids or liquids since their concentrations are constant and don't change. So in other words, if I have a brick of salt, is a big brick of salt or a little brick of salt saltier? Well, they're both just as salty, right? Their concentrations don't change. Or I'm going to drink a big glass of water because a big glass of water is a lot waterier than a little glass. Wait, no, they're just as watery. So solids and liquids have the same concentration. Why are solids and liquids concentrations constant? My neighbor has a salt lick in his backyard, and so what he does is he's got this giant salt lick in his backyard. There's our houses. And deer come along, this would be a buck, and lick the salt lick. And the idea of this is he likes to have deer in his backyard. So as he licks the salt lick, it's just as salty, so it doesn't get diluted. So it was just as salty if it's a big salt lick, and then when it turns into a little salt lick, it's still just as salty. Alright, so K. Remember, it's products over reactants, ignoring solids and liquids. So K for number 1. Our product is zinc plus 2 in brackets. I leave this out because it's a solid. Over Sn plus 2 leave this out because it's a solid. Leave this out because it's a solid. Okay? That's it for number 1. I don't have any coefficients, so I don't have to square anything. For number 2, K equals, again, it's products over reactants. I have chloride. Make sure this is balanced yet. Chloride times NH3. And notice it's aqueous and a gas. Over, I'm not going to use it, it's a solid. Na positive, OH negative. That's it. We're done. Okay? Now this one actually needs to be balanced. Okay? Now I'll give you these coefficients because they're weird. Okay? Well, I'll try and give you these coefficients because they're weird. So for number 3, my products, K equals my products, Fe plus 2 cubed times, oops, I don't include I2 because it's a solid, over, oh, really? Are you kidding me? Well, I'll do it again. K equals Fe plus 2 cubed, because there's a coefficient of 3, over, I need Fe plus 3. Coefficient is 2, so it's squared, times I negative, also the coefficient of 2 squared. And that's the third. Societies are disappearing. That's weird. Not all reactions are at equilibrium. If a reaction can get to equilibrium, it's going there. Now, it spontaneously does that. A ratio of products over reactants at any time is called Q for quotient. Q is the answer to a division problem. The formula for Q is the same. Products over reactants. Raise their coefficients. Okay. If Q equals K, then the reaction's at equilibrium. If Q is greater than K, K has too many products. Remember, we're talking about a ratio of products over reactants. If it's too big, then that means I'm going to start turning products into reactants. That's why it's going to shift left. If Q is less than K, if Q is less than K, that means I have too many reactants. I'll start making products. Okay? Because you're dividing by a smaller number. The reaction is always on its way to equilibrium. Alright, so NH4Cl plus Na positive plus OH negative yields NH3 plus Cl negative. Which way the reaction shift of K equals 0.571. So I'm going to figure out what Q is right now. So since I know the Q expression is going to be products over reactants, ignoring solids and liquids, so it's going to be NH3. Oh, come on now. Okay, I'm going to try this again. So maybe I erase these things, it'll go away. Okay, so Q equals NH3, Q equals NH3 times Cl negative over Na positive times OH negative. And then I'm going to just put the numbers in there, okay? So NH3 is 2. Cl negative is 0.75 over Na positive is 0.1 and OH negative is 0.55. I'm going to check to make sure this is balanced. It sure doesn't look balanced to me. Oopsie. Okay, so, this doesn't look balanceable. We'll just go with this. We'll pretend that this is balanced. We'll tell you this is a balanced equation. So then, let's get our numbers here. So on 2 times 0.75 divided by 0.1 divided by 0.55. 27.2. And that's Q. Remember, K is 0.571. Q is bigger than K. That means I have too many products, so shift left to reduce products and make reactants. That's it. Oh wow, look at all that stuff that's there now. Review. EQ is abbreviation for equilibrium. Equilibrium is dynamic, which means it never stops. They're always going. Equilibrium is equal rates, not equal amounts. K is a constant that can only change with temperature. Okay, that's new. Hey, did you get that? Let me highlight this. K is a constant that can only change with temperature. That's new. Write that down. All right. K equals P over R raised to coefficients. Solids and liquids are not in the K expression, and Q is P over R at some point, usually not equilibrium. And to that, I will say toodles. Toodles.